chemistry tricky questions in more than a minute this time because I found our first hard question. 4.55 grams of zinc is reacted with 50 centimeter cubic of 2.25 mole per decimeter cubed dilute hydrochloric acid. The equation for the reaction is shown. Which volume of hydrogen gas at room temperature and pressure is produced in the reaction? Okay, so they've given us the mass of zinc, which means we can calculate the number of moles for zinc. They've also given us the volume and the concentration of the hydrochloric acid, which means we can also calculate the number of moles of the hydrochloric acid. So let's calculate them. First, the number of moles for zinc. We will divide the mass by the molar mass, 4.55 over 65, which is 0.07. Now the moles for hydrochloric acid is the volume in decimeter cubed times the concentration, so 50, which was in centimeter cubed, we'll have to divide it by 1000 to get it in decimeter cubed, and then multiply it by the concentration and we'll get 0.1125. Next, we have to find which one is in excess. It may seem like hydrochloric acid is in excess because it has more number of moles, but you have to take into account the mole ratio. Here we have 1 and here we have 2. All you have to do is divide the number of moles you calculated by the mole ratio. Here for zinc we got 0.07, you'll divide it by 1. And for hydrochloric acid we got 0.1125, you'll divide that by 2. Now you can find or determine which one is in excess. Here zinc is much more than hydrochloric acid, so zinc is in excess. Now that we found which one is in excess, we're going to use the number of moles of the limiting to find the volume of hydrogen gas. So here we're going to use the number of moles of hydrochloric acid. First, we're going to use the ratio. The ratio between the hydrochloric acid and the hydrogen gas is 2 to 1. So we're going to divide the number of moles of hydrochloric acid with 2, and this will give us the number of moles of hydrogen. Now that we found the number of moles of hydrogen, we're going to find its volume. So the volume of a gas is the number of moles times 24. So here's the number of moles of the hydrogen times 24 will give us 1.35, which is option A.